Okay, I'm using the Behavioral Risk Factor Surveillance Survey. This is a representative sample. This happens to be the Pennsylvania data from 2016. So it's a representative sample of mostly the Pennsylvania adults. There's a few younger people mixed in there. Let's go ahead and take a look at t-tests. We have we're going to look at some differences between male and females here. So we're going to use an independent samples test. We're going to start off looking at is there an income difference between the two groups, and then is there a difference in the number of days of poor physical health. So this sex variable is just male or female for this data set. Males are 1, females are 2. The income has 8 different categories that go up in, let me put it up here, go up in increments. They're not equal interval increments. Just for example, a value of 8 says 75,000 or more. That could be 75,000. That could be someone making 5 million a year. They would all be in the same category. So we certainly don't have ratio, and we really don't even have equal intervals. We have ordinal data here. And if you remember, t-test really shouldn't be run on an ordinal outcome. Your outcome should be interval or continuous, or ratio, sorry. The physical health is ratio, so we'll look at that in just a second. The income, again, it's not equal interval, and even beyond that, there's something else that's an issue, and that would be that it's not normally distributed either. It's clearly not normally distributed. This is what the distribution looks like. But the JASP is not going to stop us from running a parametric test here. So let's go ahead and run it. We're going to put sex as our grouping variable, and then let's do income as our output variable here. And notice we get the test right away there. So we get p-value below 0.001, so we have statistical significance. We know that we shouldn't stop there. We know that we should look at some measure of practical significance or effect size, and let's get a confidence interval also on that effect size. So our best guess based on this test is that men make 2 standard deviations higher on income than females do in Pennsylvania. Now that 2 standard deviations is kind of tricky to interpret because we're talking about intervals that aren't even equal to begin with. But let's live with that for now. Basically, we're seeing that there is a statistically significant effect, and by this measure, it's somewhat a low effect size in terms of practical significance. And we also know that this isn't the exact, that based on our sample, we can predict for all across Pennsylvania that the difference would be somewhere between these 2 numbers here. Now the next thing we could do is we could say, well, is the variance for males the same as the variance for females in terms of how their income is distributed? And if we're not really sure that it is, then we could run a Welch test. So Welch is basically the same as a t-test. This where it says student here is the unpaired t-test that we talked about in the book. Welch is essentially the same thing. It's also a parametric test. The only difference is it doesn't assume equal variances. A lot of people would argue you should use this no matter what, because if it's not equal variances, then students is inaccurate anyway. If it is equal variances, then Welch's ends up having as much power as student does anyway. So in any case, you notice that the effect size there is pretty much the same, whether we go with the student or the Welch. But those are both parametric. Those both assume that the distribution is normal and that the variable is either interval or continuous, and neither of those are true. So that's where we may consider turning to a non-parametric test that doesn't assume that the data is normally distributed. It also doesn't assume that it's interval or ratio, and that would be the Mann-Whitney here. So if we look at those results, we see that Mann-Whitney also gives us a statistically significant result, and we're doing a two-tailed test here. We're just testing whether here we were testing the average income for males. Is it the same or different as females? Here we're more accurately testing medians if we assume the two distributions have roughly the same shape. So notice the effect size there is also positive. It's less than what we see for the parametric. And this is almost always going to be the case. Not always, but you're typically going to see the non-parametric test bring you a more conservative estimate. In other words, a lower effect size. So the question is that you're really trying to think through, is the situation more calling for a conservative effect size or a more, I guess you could say, liberal effect size here? And we have confidence intervals on each of those effect size. So one thing we could say off the bat is that the true answer is probably somewhere in between this really conservative estimate and the more liberal, or if we want to be even more precise, that for the state of Pennsylvania, the effect size is probably between this 0.09 and this 0.27. So even in the conservative case and in the lower estimate of the conservative case, we can still see that men are getting paid more than females. So, and we see that these are all statistically significant. So the simple matter is men are getting paid more than females, whether you look at the mean, the median, whether you take a conservative or a liberal test there. And I mean nothing politically by those terms. What I'm saying is you're being very cautious about what you say the effect size is, and here you're being very potentially overly optimistic about what the effect size is. So that's kind of how we look at these. Now we could check normality. I think we're going to find that they're not normal, and that's true. I mean, we saw that shape was not normal. That alone is not a big issue here because our sample size is so big. It's almost 6,000. When you have a sample size like this, it really doesn't matter the shape of the distribution. That should not be a reason for you choosing non-parametric. The parametric tests, like the student in the Welch, they'll handle that non-normal distribution just fine. You could also look for equality of variances. That is also saying that probably they're not the same variance. The way that the female income spread out is probably not the same as the way the male income is spread out. And all that's telling you is you should probably use the Welch instead of the student. But neither of these really help us make the decision between the parametric and the non-parametric, because we have a large sample size. If we had a smaller sample size, that might be more reason in this case to use the Mann-Whitney, the non-parametric. So what do we do here? Well, I think another pretty strong thing to remember is that we're not dealing with a continuous variable here. We don't have a scale or even an interval variable when we're measuring the way that we're measuring income. If we measured income in dollars per year, then absolutely we'd be fine here in terms of a scale variable, a ratio variable, but we don't have that. We have an interval where it is in order, but the intervals aren't the same size. And because of that, I think I'd lean more towards the Mann-Whitney here. I think I'd be a little more cautious in claiming a larger effect size. And you might say to yourself, well, I think that men get paid way more than female. I think this effect size is fairly strong. That may vary, and I think that is the case. The reason we're not seeing that strong effect size anywhere here, again, is because of the way the numbers were lumped together, so that one category carries everything above 75,000, when in reality you'd have a lot more super rich men that would pull up the male average much, much higher than it would the female average. And so if you really were looking at data in that way, I think you'd see a much, much stronger effect size. The other thing we could do is look as a plot here. Again, I don't know that this is super helpful. This is the males where this is where their actual sample income was. It was a little above 6 on that scale. And here the female was about 5.7-ish. But that's the averages of ordinal data. So I would take that with a grain of salt. If this was a different type of variable, these would be more useful. So I think that mostly covers the most important things to see here. What about if we, instead of running it by income, ran it by physical health? So the number of days of poor physical health, notice that ranges from 1 to 30 per month, and we're differentiating between male and female. We're checking whether there's a difference. We're not assuming that it's either direction. So again, what we see is some p-values. Notice that there's no statistical significance here. And notice also that the Mann-Whitney, the non-parametric, is even further away from statistical significance. Again, you're seeing that more conservative result play out there. Typically, you're going to see a higher p-value, a lower effect size with the Mann-Whitney, because it is being cautious. It's not assuming that the distribution is normal. And we can see here that, again, the distribution isn't normal. Here it looks like we can reasonably assume equal variances, but again, that really doesn't matter much. That tells us, oh, you can use the student instead of the Welch, which is going to be a slightly lower p-value, but really you'd be fine using the Welch. You wouldn't lose that much power anyway. So between those two, there's not really much of an issue. Here, this is a more meaningful graph for us. So we see that the average for the men, well, we could probably look at the descriptives here. The average for the men is 10.83. The average for the females is 10.6. So on average here, the men are having more days per month of poor physical health. The females are in slightly better physical health condition here. Going back to this interpretation here, it gets really tricky because we're saying that we're somewhere between this negative amount. So that would be the case where hold on, let me think through this. Okay, so the really conservative thing here would be saying that the females actually have more days of poor physical health, if we looked at the entire state of Pennsylvania, up to somewhere where the males have more days of significant health. In either direction, it's not going to be a lot. Okay, I want to go one more thing. If we go back to the original data, so we double click on the data, I'm editing this in SPSS. What I'm going to do is basically whack off the entire portion of the data set except the first 20 cases. I then ran on income t-test again with just 20 cases. Notice the results here. The two parametric ones now are saying that the females actually get paid more. This is somewhat similar to the result we saw earlier with the Mann-Whitney. Here, I really would use the Mann-Whitney because we have such a small sample size and an ordinal outcome variable and a non-normal distribution. So it does matter more.